pan by to the camera target. I'll keep these separated. It should be possible to just add these two, the horizontal shift vector and the vertical shift vector. But for now, I'm going to keep them separated. So now I'm just going to print out the camera target on each frame, just to make sure it's doing something sensible. That makes sense. Wait, can I close this? Thank you. I'll just make this non-local. One day this will be nicely encapsulated in a class. For now it's not. Okay, so now the camera's focused on the origin. If I shift, the camera is no longer focused on the origin, which makes sense. Rodrigues formula. I haven't heard of that. It's now moving in the positive x direction, which makes sense. And now the negative x direction. Let me reset this. And if I pan straight up, it's moving in the positive y direction. That makes sense. Okay. So the target, if this is working correctly, the target will always be constrained to the xy plane, which is the red one. Let me see what that formula is. The formula for the Legendre polynomials independently introduced by these two people. The name was introduced by this person, 1878, after Hermite point. Wait, what does it do? My intuition is that this isn't something that'll be... Oh, here's something about rotation. If v is a vector and r cubed and k is a unit vector describing an axis rotation about which v rotates by an angle theta according to the right-hand rule. V is a vector, k is a unit vector, k is the axis rotation, theta is theta. The rotated vector is this. That's pretty useful. It looks really arbitrary though. This is probably what I'm... Honestly, if I were to work out the algebra, this is probably the same thing I'm doing. The first term scales the vector down. The second skews it toward the new rotational position. The third term re-adds the height that was lost by the first term. Well, it doesn't make a ton of sense to me. I'll keep it in my back pocket, but first I'm going to try to do it probably the slower way that I understand. Well, let me see. This will be 3 matrix multiplications, basically. What would this be? It looks like it might be more. I don't know. I'll have to look into it some more. I'll mark it as a to-do in case that ends up being faster. But now I'm tracking this target. And since I'm tracking this, I'm going to say... Now, for rotation around the z-axis, it isn't around the z-axis anymore. Then I'm going to want to do... I don't know how to comment this. I'll just do it for now. I'm going to get a translation matrix. And then I'll just take... Whoops. Take the negative of the camera target. Can I unpack it like this? That looks wrong. Maybe like that. But I'm going to try just doing this. Robot project, what's going on? That looks wrong. Maybe like that. But I'm going to try just doing this. Robot project, what's going on? Just doing this and this. This should do nothing. This should translate it to the origin and translate it right back. Translate it so it's targeting the origin, then translate it right back. So let me run this. All the rotation code seems to be the same. If I do this, it's kind of doing what I expect. Okay. So now let's try. So I guess you can unpack like that, which is kind of weird. Got Rusty View to compile with my own crate. Now trying to migrate an existing shader to it. Good luck with that, man. I've tried migrating shaders from time to time. And that can be kind of annoying. Because once you get it all set up with one shader, getting it in a new environment can be tough. I encountered that actually when I stole the P5 shaders. I got P5 shaders to run under Manim. But it turned out the P5 shaders were just really bad, so what are you going to do? Okay, so yeah, this is negative T. So that's what I'm going to translate by. Then I'm going to do this rotation. And then I'm going to rotate back. Okay, this, with luck, now even if I translate, great, this is perfect. This is perfect because now it's, if I'm targeting a different point and then I rotate, it's going to rotate around the new point, which is similar to, you know, if I'm focused on one tree, like, I don't know, it's hard to get focus exactly on one of these trees. But here, I'm kind of focused on this tree. But if I pan, then obviously now that tree's going to move in a circle. And I'm managing to get the same effect here. So that's great. As for the rotation off the z-axis, the polar angle. But the end result, if I can get to work as a shader written in safe rest, that would be really nice. That sounds pretty cool. I thought about it some more. Eventually I'm going to have to probably port materials over into Manim. And I want to steal the materials from P5. They have some, I mean, from 3JS, they have some really nice shaders. But their shader code, like the infrastructure they use to render their shaders, is fairly complicated, unfortunately. So hopefully I can steal that. Okay. Okay, so rotation off the z-axis. I think I'm going to do the same thing. I think all I'm going to do is translate to the z-axis. Then instead of, in this case, I was measuring the angle this way. All that's going to change is I'll be increasing the angle this way. Which these drawings look the same, but this is supposed to be like in and out of the screen, and this one's supposed to be straight down. So like this. So this will be Z, and this will be the XY plane. And since this should just be done, maybe all I have to do is translate to the origin at the beginning and translate away from the origin at the end, and that's all. And then just do everything as if it were the origin. So all the way down to here, then just translate back to the origin at the end. If that worked, that would be hilarious. Okay, so here's my rotation. Here's panning. This. It's not doing anything crazy. It's not like going off axis or anything. I think it's working. I think it's working. Which is hilarious. All right, I'm gonna operate off the assumption that that's working. That was much easier than I expected it to be. By just translating to the wherever and translating back. To say translate to target the origin. Translate to target the original target. Other than that, I just rotate around the z-axis normally. Rotation off of the z-axis, the polar angle, seems like it's more complicated than it needs to be. Although a lot of the logic is just dealing with minimum angles and maximum angles, so I think that's okay. Now it'd be really cool if I could implement damping, which is when I rotate really fast and it keeps going for a little while, or pan and it keeps going for a while. That'd be super cool. What I think I'm going to do now is just try to implement zooming with the scroll wheel. I think it's also safe to add these vectors, so I'm going to try doing that as well. Let me start with some refactoring. Move this down here. Then I should be able to just do full rotation or something. Wait. One of these is a cross product. One of them isn't. I think I'll just compute another vector. Total translation or total shift is the horizontal shift vector plus the vertical. And then I can save a matrix multiplication, which is always nice. I could probably unpack this more, like just... this horizontal shift? Is this only used in one place? It is. So I don't think it makes sense to have that variable there. Then this is also only used in one place. And let me put the negative somewhere normal. Okay, so this is what we get. I think that's a fairly reasonable logic. Rust is big with WebAssembly. That's true. I wanted to learn Rust almost specifically so I'd be better with WebAssembly. So I could use it with WebAssembly. Okay, that's a pretty neat effect. So let me stop the printing. This rotate to the original target. Cool. So now let me try to do the zooming, which is the last part of basically these controls. And there's already a hook for zooming, but I won't use on-mouse drag. I'm just going to use on mouse scroll. I don't know the signature. Let me find that. I guess we get a point and an offset. I'll do nothing for now. Get a point and an offset. I'll do nothing for now. Whoops. I have so many shortcuts that sometimes I end up using the wrong one. Oh my gosh. Oh my gosh, I did it again. I'm probably gonna end up redoing my Vim configuration in the near future. It's really fast, but it always gets to a point where there's so many shortcuts that they begin conflicting with each other. Okay, so now this won't do anything when I scroll. Actually, that's not what I want. I want it to just print something. So I can make sure I hooked into it correctly. And well, it worked, sort of. It's missing an argument. Oh yeah, when you override a method like this, you have to not pass self, and I don't know why. Yeah, but anyway, now I can do the scroll logic. I think the scroll logic is fairly simple, thankfully. I'll need the target. Then all I'm gonna do is wherever the camera is, the origin will be somewhere, the target will be somewhere else, and the camera will be looking at the target. And I just want to decrease this distance. So move the camera in the direction of the displacement vector from the camera to the target. So I'll know this vector, this is t, and I'll have the camera's location. So this is t minus the camera location. So I just have to move it in that direction. Though I don't know... How do I tell if the scroll is forward? Offset. What even is offset? What is point either? Was it called camera target? It looks like offset is the location of the cursor. No, point is the location of the cursor. And then offset is this random number, and it's just positive. It's positive if you scroll up and negative if you scroll down. Okay. So what I'm going to do, I'm going to say zoom direction, and that'll be the sign of offset. I think that's all I need. Although this sign function is sort of janky. I think if you give it a 0... Wait, if you give it a 0, oh... My darn terminal is offset. I'll try this one. Nope, there we go. 0? It isn't doing it now. This thing has given me -0 in the past, and it's caused problems. Maybe if you give it a -0. No? I don't know. It's not doing it now that I put it on this spot. So I need camera to target. This is T minus C. Self.camera.get position. Cam era to target. No, I did it. Self.camera.get position. Cam era to target. No, I did it again. Camera. There we go. And then if zoom direction is greater than 0, then I want to translate it in that direction. So it'll be like this. Camera to target. Okay. Otherwise... Oh, what I should do is just... camera to target. Target times equals the zoom direction. And since this variable is only used in one place, I'll just end up doing this. And then... just translate the camera by that vector. Alright. That did not do what I expected. I actually don't know what it's doing, but it isn't correct. Okay, why would that go wrong? Translation matrix star camera to target. It seems like it makes so much sense. Here it's not doing anything, as far as I can tell. Camera target minus camera.get position. That seems right. Multiply by the sign. I'm gonna print the vector. And then print the camera's new position. So the camera position is not moving, and it's giving me all zeros for camera to target. Which is oh, I'm doing camera to wait, camera target minus camera target starts at the origin, right? Something fishy. Camera target. So this should be the origin when I first start. And it is. So this. Wait. Did I freeze something? Oh, okay, so -11. I think this makes sense. This is from the camera to the origin. Yeah, so that should be -11, that's right. So why is it that when I translate by that much, nothing happens? camera to target times equals the sine of the offset. That won't change. That will probably change basically nothing. No, that turned it to a 0. Okay. I knew not to trust this numpy sine function. What is offset and what is... Okay. Normally, I would use PDB here. But it doesn't work with interactive whatever. Okay, so this is the offset, this is sine of the offset. I guess all I want is the second entry. So let me just do that. So 1 and then 1 here. So 1 and then 1 here. Did it work? Well, my cube vanished, which might make sense if I'm moving by too much. Let me print the camera to offset again. To target. So it'll just shift it by 0, 0, negative 11. And it makes sense actually that this would... It makes sense that this would move it out of vision. Because the camera, by default, is only 11 units. Here. This is 11 units above the origin. And so if I move it forward by 11 units, the camera will be right here. And so it makes sense if it can't see the square, I guess. Also, since this is translating the camera, I have to translate the target as well. So let me do camera target plus equals camera to target. Wait, hold on. I have to scale this down. So the shift vector. Let me do like 0.1 times that. And I'm gonna add that to the camera target. Okay. Still vanished. I'm gonna get something even smaller. Oh, I didn't do the shift vector. Okay. Okay, eventually. Okay, this makes more sense to me, I think. Okay, I think this makes more sense to me. What I should be seeing now is if an object leaves the field of view of the camera, this is going to be hard to explain. This is how orthographic projections work. Actually, do I have an article about it here? I think this website goes over projection matrices. Okay, so normally cameras have a field of vision frustum. A frustum like this. It's like a part of a trapezoid or part of a pyramid. But if you project orthographically, it isn't this cone shape. It's a box like this. And so if things go outside that box, which here I'm zooming out, I'm getting further away from the object. As they leave that box, it's going to start disappearing because it's no longer in the field of view. Then if I zoom back in, it'll come back into the field of view. until eventually I pass through it like that, and then it disappears from the front. I say all that to say I think it's working. And the only reason it's... Well, I feel like... I think, yeah. It would look more apparent if I did a 3D projection. If I did... I think it's called a perspective projection. But I didn't do that. But I think this is all working, actually. Which is cool. So here, I'm going to commit this stuff. I wonder what change I made to OpenGL rendering.